All right, for 5.1 and 5.2, we went through the exponent rules pretty quickly, and if there were parts of, if there were sub parts of this that were not, that you weren't super solid on, it is valuable to go back. Specifically with dividing, often when we are dividing or we have fractions, and you're not super solid on what to do with fractions, and then adding exponents can be quite intimidating. So it is worth it to, if there is any confusion, to go back and make sure that you are okay with fractions. And then before you even add the exponent rules, maybe if necessary. So what we're doing is we're just simplifying. We're making it into the simplest form of that equation. So for example, this fraction that has no exponents or variables, 84 over 180, is the exact same as 7 over 15. So if you put 7 divided by 15 into your calculator, you're going to get the exact same number as if you were to put 84 over 180 into your calculator. Okay, and then x to the fourth over x to the sixth is the same as 1 over x squared. So with all of these examples, you're just going to be, it's going to, you're not solving anything, you're just making an equivalent that's more simple, that looks simpler, but has the same value as what they gave you. Okay, so reducing fractions, whether we're talking about exponents, whether we're talking about letters or numbers, what you're doing is you're dividing out factors from the numerator and the denominator. So when you think of fractions and simplifying it, you're dividing out factors from the numerator and the denominator. Remember, the numerator is just the top of the fraction. The denominator is the bottom of the fraction. So you've got your numerator and you've got your denominator. Okay? Divide out factors. For example, 84 over 180. One way of doing this is to list out the factors of each number. What that means is if you were to make a factor tree of 84, 84 is equal to 2 times 2 times 3 times 7. Let's check. 2 times 2 times 3. Divided by times 7 is 84. Okay, so what these are is they are the prime factors of 84. The way you find the factors of 84 could be, you take 84. You think, what can I divide 84 by? It looks like I could divide it by 2 because 4 is even, or I could try dividing it by 4, right? It doesn't matter. Choose either of those that you want. 84 divided by 4 is 21. So 84 becomes 21 and 4. Good? 21 times 4 is 84. Okay? Those are two factors of 84. What are two factors of 21 now? I know I can divide 21 by 7. 21 divided by 7 is 3, right? 4 is 2 times 2, right? So 4 factors to 2 times 2, 21 factors to 7 times 3. 7 times 3 times 2 times 2 is 84. I think we just did that up there, right? 7 times 3 times 2 times 2 is 84. I can't, 7 is a prime number. There's nothing I can divide by 7 by except 1. Nothing I divide 3 by except 1. Nothing I can divide 2 by except 2 and 1. Nothing I can divide 2 by except 2 and 1. So those are prime factorizations. There's no simpler number we can divide it by. So we call this the prime factorization of 84. 84 is 7 times 3 times 2 times 2. Okay. What was our other number? 180. Oh, no, let's do 84. Let's do a different way just to show you that you don't need to worry about how you're going to factor it. So I said maybe we can divide it by 2 also. 84 divided by 2 is going to be 42. So I can call it 2 and 42. 2 I know is prime, right? So that's just going to stay as a 2. 2 times 42 is 84. 2 remains 2. 42, I'm just going to divide it by 2 again. 42 divided by 2 is 21. So 84 is still 21 times 2 times 2. 2 remains 2. This 2 is now a 2. 21, the only factors are 3 and 7. So you end up with the same factors no matter how you start. Okay, you could also say 84 and straight away divided by 7, right? 84 divided by 7 is 12. 7 is a prime factor. 12 is 4 and 3. 4 is 2 and 2. So you still end up with 3 times 2 times 2 times 7. Good? Doesn't matter what you do, you'll always have a 7, a 3, and 2 2s as your prime factorization for 84. Okay? Now 180. 180, again, start wherever you want. It's kind of helpful if you start with big numbers, I think. But you don't want to get stuck. So if you want to start with a really small number, that's fine. So 180 divided by 10 is 18. That makes sense, right? 10 times 18 is 180. 10 can become 2 and 5. 2 is prime. Ew, 5 is prime. So we're done. You can't divide either of those by anything. 18, I can say, is 9 and 2. 2 is prime. 9 is 3 times 3. So I think 2 times 5 times 3 times 3 times 2 is 180. So I found the prime factorization of 180. That is how they got these numbers, okay? So I'll just rewrite what they wrote. They wrote 84 over 180 is 7 times 3 times 2 times 2 over 5 times 3 times 3 times 2 times 2. So we just turned it into the smallest factors we possibly could, okay? Now, any factor that is common to the top and the bottom, you can factor out, it's called, okay? So there are no 7s in the bottom. There's 1 7 in the top. There's a 3 in the top and a 3 on the bottom. There's a 2 on the top, 2 on the bottom, 2 on the top, 2 on the bottom, okay? You have factored out everything you can, and you are left with 7 over 5 times 3, right? Or 7 over 15. So anytime you have a fraction and they ask you to simplify it, this is a good way to simplify it. Find the prime factorization of that number, the prime factorization of the bottom number, cancel out what you can of those prime factors and leave it as is. So 7/15 is 84 1/80. Okay? You can only do factors that are multiplied and not terms that are added. Okay? If it was 4 plus 9, that's all one factor. It does not reduce, okay? You can't divide out the 4s. 4 plus 9 over 4 plus 12 is 13 over 16, which is not the same as 9 over 12, right? 9 over 12 is not going to equal 13 over 16. Those are not the same number because of that plus sign. Here, it was all multiplication. So those are all factors, but 4 and 4 are not factors here because we're adding instead of multiplying. But don't worry about that because you're not going to see anything like that. It's just an explanation. And just to prove, 84 divided by 180 is 4.46, and then 7 divided by 15 is 0.46. Now, that's how you reduce the fractions that are numbers. And then often the numbers are going to be right next to a variable. If you notice the variable, you do the same idea as when we divided numbers. So when we divided numbers, we canceled out what was common to the top and the bottom. X to the 4th, remember that's just going to be 4 x's. X multiplied times itself 4 times. X to the 6th is just going to be x multiplied by itself 6 times. Good. So x to the 4th over x to the 6th is going to look like this. And then again, those cancel, those cancel, those cancel, and those cancel. What I get are 2 x's on the bottom nothing on the top, but it's not 0. It's just a 1. Okay. 1 over x times x is the same as 1 over x squared. So that is how we're doing it. That's how you reduce fractions, either with variables or with whole numbers. Okay. Here we have x to the 7th over x to the 5th. We are going to write 7x's on top, 5x's on the bottom. They're all multiplied by each other. And then we're going to eliminate 5 of them. So we have 2 left on the top. X squared over 1, which is just x squared. Okay. So, for example, A is 12 times x to the 5th. A is 12 times x to the 5th over 8 times x to the 12th. Because when they're right next to each other, it does mean multiply, okay? What you can do is you can change this to 12 over 8 times x to the 5th over x to the 12th, okay? 12 over 8, again, we can treat it just like this. 12 can become 3 times 4. 3 times 4 is 12. 3 is a prime factor already. 4 is 2 times 2, right? So 12 is 3 times 2 times 2. And then 8 can become 2 times 4, right? 2 is a prime factor. 4 is 2 times 2. 2 times 4 is 8. And 2 times 2 times 2 is 8. So 12 over 8 becomes 3 times 2 times 2 over 2 times 2 times 2. What can cancel? This cancels with this cancels with this. I'm just left with 3 halves for the 12 over 8, okay? 12 over 8 is now 3 halves. X to the 5th over x to the 12th. Got 5 x's on top. Twelve x's on the bottom, hopefully. Not that good at counting. I can cancel out 5 of them, right? And so we are drawing it out and counting, but it is also subtracting because we took all 12 and then we subtracted 5 from the 12. So 12 minus 5 is 7. Hopefully there are 7. 1, 2. Yay, there are 7. Okay. So we have 3 halves times, there's nothing on the top, and there are 7 x's on the bottom. So that becomes 3 over 2x to the 7th. Okay, because the 3 times the 1 is just 3. 2 times x to the 7th is just x to the 7th. 3 over 2x to the 7th. Good. B, 12 x to the 5th, y to the 12th, I'm out of room, over 20 x, y to the 15th. Okay, well, first let's do 12 over 20. 12 we know is 3 times 2 times 2. What do we know 20 is? Let's do 20. 20 is going to be 10 and 2, right? 10 is going to be 5 and 2. 2 is going to remain 2. 5 times 2 times 2 is 20. So that's my prime factorization of 20. 5 times 2 times 2. Okay, so on the top, I have 3 times 2 times 2 is equal to 12. The 12 is 3 times 2 times 2. The 20 is 5 times 2 times 2. What can I cancel? I can cancel the 2 and the 2. So that is not easy to see with the green. That is 3/5. Okay. Then we have x to the 5th over x, right? What cancels? Only one x cancels. So that's going to be 3/5 with some x's next to the 3. How many? 1, 2, 3, 4. X to the 4th. Okay. And finally, we have 12 y's. And then we have 15 y's on the bottom. You can draw them all out and eliminate them. You can eliminate 12 out of those bottom 15, and we are left with 3. We have 3x to the 4th on the top over 5y to the 3rd. Because 5 minus 1 is 4. 12 minus 15 is 3, but the bigger number was on the bottom, right? There were more y's on the bottom. So those remaining 3 y's are going to stay on the bottom. The x's, there were more x's on top. So those 4 remaining x's are going to stay on the top. So this one is 3x to the 4th over 5y to the 3rd. All right, let's do 9x to the 2nd over 9x to the 2nd over 36x to the 6th. 9 is going to be 3 times 3. Oh, that's what you do. 36 is going to be 6 times 6, right? 6 becomes 3 times 2. And the 6 also becomes 3 times 2. So 3 times 2 times 3 times 2 is still going to be 36. And then 3 times 3 is going to be 9. So 9 over 36 becomes 3 times 3 over 2 times 2 times 3 times 3. Again, nothing on the top, but you don't put a 0, you just put a 1. 1 over 2 times 2. But 2 times 2 is 4, so I'm going to call it 1 over 4. X squared over x to the 6th. So that's just x times x over 4 times x 6 times. Good. What can I cancel? I can cancel this x and I can cancel this x. So it looks like everything's on the bottom, but don't worry. You can just bring back that 1, okay? When there's nothing on either the top or the bottom of a fraction, when you cancel everything out and there's nothing up there, you put a 1 just to hold place, okay? 4, and then how many x's? 4 x's. 1 over 4x to the 4th. So let's just a quick example about the 1, okay? If I had 4/12, right? 4 becomes 2 times 2. 12 is 2 times 2 times 3, right? Let's check that. 2 times 2 times 3 is 12. 2 times 2 is 4, right? And then what can I cancel? I can cancel the 2's, and I just have a 3 on the bottom. There is nothing on top, right? But if I put in a 0 divided by 3 is going to be a 0. 4 divided by 12 does not equal 0, right? It equals 0.3333. There's nothing up here, but nothing over 3 is nothing. What about if I just keep that placeholder, 1 over 3? That's the same thing, okay? Just like if it was 12 over 4, that would be 2 times 2 times 3 over 2 times 2. Those would cancel and it would just be 3 over, is it 0? 3 over 0? 12 divided by 4 is 3. 3 divided by 0 is not the same thing, okay? 3 divided by 1 is the same thing. So when we're dealing with fractions, we never just add a 0 when we cancel everything out. We add a 1 as the placeholder, okay? It doesn't change the value. 0 would change the value. 1 doesn't change the value. So that one is 1 over 4x to the 4th. Okay. You just do a few more of these exercises. 14x to the 3rd over 2x. So we have 14 over 2. What is 14 going to be? 14 is 7 times 2, right? Those are both prime. You're done. 14 is 7 times 2. 2 is just 2. We can cancel out the 2's and we're left with 7. And then we have x to the 3rd, which is 3x's over x. That gets canceled. And what we are left with is 7x squared for number 1. Okay. 35 over 45. X to the 12th. Remember, you can think of it totally separately over x to the 7th. So 35 is 5 and 7. 45 is 5 and 9, right? You can call 9 3 times 3. 5 is still 5. Here, 5 is a prime and 7 is a prime. So 35 over 45 becomes 5 times 7 over 5 times 3 times 3. 5's cancel, and you get 7 over 3 times 3, or 7 over 9. And then x to the 12th over x to the 7th. Remember, you can write out all the 12s, write out all the 7s, but what we're doing is we're subtracting the 7 from the 12. So 7 over 9, x to the 12th over x to the 7th is 7, 9, x to the 12 minus 7, right? 12 minus 7 is 5. 7x to the 5th over 9. For number 2. Okay. Number 3 is 25 m to the 5th over 75 m to the 6th. Think about what 25 is. 25 is 5 times 5. 75, if you think about it, you can take 75 and you can divide it by 25. 75 divided by 25 is 3. So 25 is 5 times 5. 3 stays the same. 5 times 5 times 3 is 75. 5 times 5 is 25. Good. So 25m to the 25 becomes 5 times 5. 75 becomes 5 times 5 times 3, right? What can I cancel? The 5's. So that becomes, remember we keep a 1 when we factored out all the other factors, 1 over 3, and then we have m to the 5th on the top, m to the 6th on the bottom. There's 5 m's on top, there's 6 m's on the bottom, so that's going to leave me with 1 m on the bottom. m6 minus 5 is 1/3 m to the 1st, or just 1/3 m. Good. So we have 1 over 3m. 8x over 4x to the 5th. Eight is 3, nope, sure isn't. 8 is 2 times 2 times 2. 4 is just 2 times 2. So we just have 2 on the top. There's nothing on the bottom, so you can put a 1. And then we have 1x on the top, 5 x's on the bottom. We can cancel out one of the x's. So that is 2 on the top. 1, 2, 3, 4. I don't think I wrote enough x's. Sorry, 2 on the top, x to the 4th on the bottom. Okay. Or you can say 5 minus that 1 is 4. Just like 6 minus that 5 is 1. Whichever number has the bigger exponent, that's where all of your remaining exponents are going to go when you subtract. So 8x over 4x to the 5th is equal to 2 over x to the 4th. All right. 26x to the 9th over 6x to the 7th. 26 becomes, I don't know, 26, you can divide it by maybe 2. You get 13. 26 is 13 times 2. 6 is, and you see that you only have the factors 13 and 2. You can't divide it by 13. Maybe you can divide it by 2 though, because you want to eliminate common factors. 6 divided by 2 is 3. So 26 over 6 becomes 13 times 2 over 3 times 2. And then we have 9 x's. And we have 7 x's on the bottom. What's going to be left over? 2 x's on the top. Oh, sorry. And we eliminate these 2's. So we have 13 over 3. And then we have 2 x's left over on the top. 9 minus 7 is 2. And let's get down to something with more variables. So number 7 is going to be 14 x to the 3rd y over 16 x y to the 3rd. Okay, remember that this only applies to the nearest variable or number. Okay, so 14 over 16. 14 is what? 7 times 2. 16 is maybe 4 times 4. They both become 2 times 2. So 14 is 7 times 2. 16 is just a bunch of 2's. 2 times 2 times 2 times 2. I can eliminate one of the 2's. So that becomes 7 over 2 times 2 times 2 is 8. Okay. So 14 divided by 6 is the same as 7 over 8. And then we have x to the 3rd over x. What's that going to be? X to the 3rd means there are 3 up here. X just means there's 1 up here. 3 minus 1 is 2. So that's 7x squared over 8. And then don't forget the y's. Y over y to the 3rd. So that looks like 3 y's down here. 1 y up here. Cancel those. And we have 7x squared over 8y squared. Good. Number 8 is difficult. 8 is 10x squared y to the 8th over 15 x to the 6th y to the 5th. And there's a negative in front of it. I think it's why it's difficult. That negative, I'm just going to keep it out in front. Okay, there's just a negative out in front always, no matter what. So 10 becomes 5 and 2. 15 becomes 5 and 3, right? So that is now negative 5 times 2 over 5 times 3. Notice I'm not putting the negative up on top or down below. I'm just keeping it out in front, okay? 5's cancel, and I have 2/3. Negative 2/3. X squared is x times x. X to the 6 means there are 6 of them. Now there are 4 of them, so that's negative 2/3 x to the 4th on the bottom. 6 minus 2 is 4. Now we have 8 y's. 5 y's on the bottom. What can cancel? 5 of the y's get canceled. Negative 2/3 x to the 4th y to the 3rd up on top, because 8 minus 5 is positive 3. Good. So that's 2y to the 3rd over 3x to the 4th. Number 9, negative 4x to the 3rd y to the 5th over 18x to the 3rd y squared. So 4 I know is 2 times 2, right? 18. 18 is just 9 and 2. Right? It could be 3 times 3 times 2, but 9 and 2 gives me one factor. So 4/18 is the same as 2/9. X to the 3rd over x to the 3rd, they completely cancel, right? There's 3 x's on top, 3 x's on the bottom. They all cancel. Y to the 5th over y squared. Two of the y's cancel. So my final answer is 2y cubed over 9. All right, so before I go on with 10 or 11 or 12, I do just want to very much emphasize that these negatives just remain negative, okay? I know that a negative divided by a positive is always going to give us a negative. A positive divided by a negative is always going to give us a negative, and a negative divided by a negative becomes a positive. So I wouldn't worry about if it's here or here. It's just out in front. It's negative because one of these two would be negative if you had to make them negative. It doesn't really matter which one it is, okay? So if my math lab gives you something like negative 4 over 2, I just put it out in front, okay? It's just a negative of everything. Negative 4 over 2. Negative 2 is your final answer, right? So you're just putting negative in front of your answer. Don't worry about where it goes, if it goes at the top or if it goes at the bottom. Just keep it out in front, because all we're doing is factoring out numbers. So it's never going to factor out a negative, okay? The negative is just going to stay in front no matter what. Number 8 began negative, it will end negative. Number 9 began negative, it will end negative. There's no way that you can simplify it out of the negativity unless it's negative 33 over negative 22. If you see that they are both negative, you just immediately make them positive, because 33 divided by 22 is that. Negative 33 divided by negative 22 is a positive, okay? So if you see negative, before we go to 10, negative 33 over negative 22, that's the same as both the negatives disappearing, okay? If it's negative 1/3, just make it negative out in front, 1/3, okay? Just be very careful with the negatives. Only if there are two negatives, make it positive. Otherwise, just put it way out in front. Don't worry about who it's with, okay? That whole thing is negative, no matter how you simplify it. 4/18, negative 4/18, 4 over negative 18. Those are the same, right? Negative, comma, 4, or sorry, parentheses, 4/18. Those are all negative. This one I didn't add a negative to, right? So that's the positive version. Negative on the top, negative on the bottom, negative out in front, all exactly the same, okay? And we reduced 4/18 to 2/9, negative 2/9, same answer, okay? So you're just simplifying. So the negative, just leave it out in front. Ignore it. So we have 33 over 22 for number 10. 33, we can divide it by 11, I think. It's 11 times 3. Sorry, this is sloppy. I just did that little riff and now it's hard to look at the rest of it. All right, 10 is 33 x to the 6th, y to the 9th, over 22 x to the 4th, y to the 8th. Good. 33, I can divide it only by 11, and it's 11 times 3. Okay. Once you know your factors, you're kind of looking for those factors. Sorry, 22. Been doing too many factor trees. I just made 22 into 2 times 2. Not helpful. When you know you're trying to factor something out, look at the only 2 factors your other number got. So can I divide 22 by 3? No. Can I divide it by 11? Yeah. And it is 2, right? So 33 is 3 times 11. 22 is 2 times 11. That means I can cancel out my 11. So that becomes 3 halves. X to the 6 means I have 6 x's. X to the 4th means I have 4 x's. Before you go on to your y's, I suggest canceling out the x's so you feel like you've accomplished something. That's what I do. So now you're mostly done, right? I have 2 x's left. And then y to the 9th over y to the 8th. I think I'm just going to have one y on top, right? 9 here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8 on the bottom. 1, 2, 3, 4, 5, 6, 7, 8. Good. And we're going to cancel out all 8 of them. So that means these 3 and these 3, these 3, and these 3. 2 out of these 3. So I just have one y on the top. 3x squared y over 2. Because the 6 was bigger than the 4, the x stayed on top. Because the 9 is bigger than the 8, the y stayed on top. Good. All right, 11. They're giving us 3 over 30 times x to the 5th over x to the 6th times y over y to the 8th. Good. 3 is already in its simplest form. So 3 is just 3. 30 is 3 times 10, right? Because the only factor I'm looking for is a 3. That just becomes 10 on the bottom, x to the 5th, y on the top, x to the 6th, y to the 8th on the bottom. So now I have 5 x's and 6 x's. No x's on the top, just a y on the top now. 10x y to the 8th, right? Because we canceled out the 3. So then there was no 3. We canceled out all the x's. There's just one x on the bottom. 5. 6 minus 5 is just 1 on the bottom. Now we have y on the top, y to the 8th on the bottom. One more time. Y over 10x times 8y's. Good. Oh no, there's nothing on the top. Remember, that means we put a 1 on the top or the bottom, whatever it is. 10, 1x. How many y's? I canceled that one. 7. So 30 divided by 3 is 10. X to the 6th divided by x to the 5th is x. Y to the 8th divided by y is y to the 7th. Okay. And let's just do one more. Let's do number 12 and call it good. So 12 is 7x to the 4th y squared over 49xy. Good. 7 is already prime, just like 3 was, so you don't need to do anything. 49 is 7 times 7, right? So that's 7 over 7 times 7 times x to the 4th over x times y squared over y. All right, what can I cancel? 7, one of the x's, one of the y's, and I get x cubed on top, y on top, 7 on the bottom. All right, my math lab might give you something like this. Again, I didn't leave myself much room at all. I strongly encourage you, if you see one negative sign, so the top term is negative, the bottom term is positive, that's always going to give you a negative number. -1 divided by 2, -6 divided by 9, -3 divided by 1. It's always going to give you a negative, okay? So I would take that negative, put it out in front, okay? All of this is now negative. 8 over 4. Remember what 8 is. 8 is 2 times 2 times 2, because 8 is 2 times 4. 2 is prime. 4 is 2 times 2. So 8 is 2 times 2 times 2. 4 we know is just 2 times 2. So 8 over 4 is just the number 2. -8 over 4 is just -2. Okay, but that negative is out in front. We don't need to make the 8 negative, make the a negative, make the b negative, and make the c negative. We're just putting it all out in front, okay? So 8 over 4 is 2. A to the 7th over a squared. Remember, you can take 7 minus 2 and get 5, or you can say these are 7 a's. And these are 2 a's. And then cancel them. And count how many you have left. So we still have 2, right? Negative 2, a to the 5th, because 7 times 2 is 5. Now we have b to the 5th over b to the 3rd. What cancels? 3 of the b's cancel. Remember, negative out in front. 2 a to the 5th b squared times, now I have 14 c's on top, 12 c's on the bottom, okay? If I write that all out, 14 c's and 12 c's, I will have 2 c's on top, right? There's nothing on the bottom. This number canceled out this number. This number is two of these, right? This number minus this number is this number. This number minus this number is this number. And this number minus this number is this number. So these were all so much bigger than these that there is nothing on the bottom. So I can say it's over 1, or I can say it's just that.